Greetings everyone. In this video, we will talk about data structures and especially arrays in C++. So let us see what is a data structure. The organized collection of data along with the methods of accessing and manipulating data is called a data structure. In other words, we can say data structure is organized data plus allowed operations. So we look at the example of data structures. These are arrays, linked list, etc. Now, types of data structures. Data structures can be classified into different categories based on different criteria. So, let us look at the different categories and different criteria. So, based on data types, data structures are divided into two types, simple and compound. Simple, they are built from primitive data types, for example, int, char, etc. And compound, they are built from simple data types and they are combined in various ways to make compound data types. Example, arrays. Based on layout, data structures can be of two types, linear and non-linear. In linear data structures, the data items are arranged in a linear sequence. An example of this is arrays, stacks, queues, etc. In a non-linear data structure, the data items are not arranged in a linear sequence. An example of this is trees. Now, based on types of elements, data structures can be homogeneous and non-homogeneous. Homogeneous data structures, in this, all the elements are of the same type. An example of this is arrays. And non-homogeneous data structures, the elements may or may not be of the same type. An example of this is records. Based on the type of memory allocation, data structures can be static or dynamic. In static memory allocations are fixed and they are done at compilation time. Example of this is arrays. In dynamic memory allocation, the memory allocation is done during runtime and we are free to allocate memory as and when required. An example of this is linked list. Now, introduction to arrays. Let us understand what are arrays. An array is a collection of finite number of homogeneous data elements. Finite means fixed number. We cannot have infinite array of infinite number of elements. Homogeneous means all the elements of the data, they are of same type. We cannot have one element as int, the other element of char, the other element of float. All the data elements, they must be of the same type and they are stored in contiguous memory locations. Contiguous means one after the other. As you can see here, this is an example of array in which all the elements are stored one after the other. Now we cannot have the element 0 here, then 1 here, then 2 here in a haphazard fashion. They must be stored in contiguous memory locations. Each element of the array is accessed by the same name but different index number. So if the name of the array we say is B, then all the elements, they will have the same name B, but they have different index number like 0, the first element 0, second element has index number 1, third element has index number 2, fourth element has index number 3, and fifth element has index number 4. And very important to note that index numbers of the array, they start from 0 and not from 1. So you can see here, the first element has index number 0 and not 1. It is important to note down. The first element has 0, the second element has 1 and so on. Now let us see the syntax of creating an array. First we have to mention the data type, which type of array we want actually. Then we give the name of the array and then within the square brackets we give the size of the array. So if we see a look at the examples, this is int a10. It implies that the array is of type int and the name of the array is a and it has 10 elements. It means A is an array with 10 elements and all the elements are of type integer. So if we talk about the second example, float B5. This shows that B is an array of 5 elements and all the elements are of type float. So this array has been depicted here also. You can see here it has 5 elements from 0 to 4 and all the elements are of type float and they have the same name B but different index numbers. Now let us see what operations can be performed on arrays. Following set of operations can be performed on the arrays: traversing an array, inserting an element in the array, deleting an element from the array, searching for an element in the array, sorting elements of the arrays, and merging elements of the arrays. So out of these operations, in this video, we will talk about traversing, inserting, and deleting, and rest of these operations we will talk in our next videos. Now let us see what is traversing an array. The term traversing implies visiting each and every element of the array exactly once. It means we are going to each and every element of the array and we are trying to perform some operations. We are trying to display the elements of the array, or we can perform any calculations on each and every element of the array. This we can do for while traversing an array. Array is traversed to process each element of the array. Now I have written a very simple program to see how traversing can be done. So these are the two header files, iostream.h or conio.h. And this is void main. Now here I am declaring an array of type integer which has 6 elements from 0 to 5. And here I have initialized the array also with 6 elements 10, 20, 30, 40, 50 and 60. And I is an integer which I have used in the program. And clear screen is used to clear the screen, and the header file of this is conio.h. Now I'm displaying my array is on the screen, and then this is the for loop. For I is equal to 0, I less than 6, I plus plus. I'm displaying each and every element of the array. Let us see how this loop works. So this is my loop. I is equal to 0, I less than 6, I plus plus. So in the beginning, I is equal to 0, which is less than 6. So condition is true. So we'll go to this statement. So we can see here, this is my array. So when I say I is equal to 0, A0 equal to 10. This is the zeroth element. This is the first element and which has the index number 0. So when I say cout AI, cout A0 will be displayed and the value of it is 10, which is displayed here. Now when we go up again, the I will be incremented and I will become 1. 1 again is less than 6, so the condition is true. So it will display the statement, execute the statement. Here the I is 1 and A1 is 20. You can see this is the first element of the array and this is A1 is 20. So 20 will be displayed here. Now again the I will be incremented. This time I will become 2 and 2 is again less than 6. So the condition is true and this statement will be executed. So when I is 2, A2 is equal to 30. So this is A2. This is 0, 1 and this is 2. So A2 is equal to 30. So 30 will be displayed in the output. So again I will be incremented. I will become 3, which is less than 6. So I is 3. This is I is equal to 3. So A3 is equal to 40. So this is 40. So A3 will be displayed. So 40 will be displayed here. Again I will be incremented. I will become 4. And now A4 is equal to 50. So this is A4 and which is equal to 50. So A4 will be displayed and this is 50. Again I will be incremented and I will become 5. So A5 is equal to 60. You can see this is the fifth element and this is equal to 60. So 60 will be displayed. So again I will be incremented and this time I will become 6 as you can see. And 6 is not less than 6. The condition is false. So the loop will terminate. This is the output of my program. Now next let us learn how to do insertion in the array. Insertion refers to the operation of adding new element to the array. I already have an array and I want to insert a new element to the array. Now it can be done in two ways. You can specify the position at which the element is to be inserted. In this case, you may or may not have array to be sorted. And in any array, I can specify the position where I want to insert an element and I can run the program. And in the second case, inserting an element at the appropriate position in the sorted array. In this, the array is sorted. So I have to search the position first where I have to insert the element and then I will insert it into the array. Now for these operations, let us assume that we have A as an array. N is the total number of elements present in the array. Max is the maximum number of elements that can be inserted in the array. That is the size of the array. If N reaches max, then it means the array is full and no more insertions can be done. An item is the element to be inserted in the array. Now let us see, in the following program, we will insert an element at the given position of the array. So we will start our execution from main. You can see I have included two header files, iostream.h and process.h. process.h is for the function exit. Then I'm declaring a constant global variable max equal to 8. And then in main, I'm declaring an array num, which is of size max, and it has some elements beforehand. These elements are present in the array beforehand. And so n is 6. You can see there's already 6 elements and the size is 8. And at position 3, I want to insert data 40. So I will call this function insertion, in which I am passing name of the array, and then I am passing the total number of elements present in the array. Then I am passing the position at which I want to insert the data and the data which I really want to insert. And this is the function. In this function, this is the insertion function, in which a is the name of the array which I have received. These are the formal parameters which I have received from main. Then int ampersand by reference, I am sending the total number of elements, because in this, after inserting, the number of elements will increase. And then I'm passing position where I want to insert, and this is the item, the data item which I want to insert. So let us first check this program, and we'll do then the dry run of this program. So I'm saying if n equal to max, it means if the number of elements which are present in the array is equal to the size of the array, then the maximum number of elements that can be inserted into the array. Then if they are same, it means this is overflow and new element cannot be inserted. And so we will exit from this program, because no more insertions can be done. And if this is not the case, then we will move all the elements from the end till the position where I want to insert the element one step down. We will see how this will work, and then we will insert the item which is to be inserted at this position. And I will increase the number of elements by 1, because now one more element has been added to the array. So let us see the dry run of this program to understand it more comfortably. So first we will look at the how the allocation of memory is done to variables. So you can see here I have divided the memory into 3 sections: global variables, main, and insertion function. There are 3 things. Now this is the constant int max equal to 8 is a global variable. So this will be declared here, and the value it will be given, it will take the value 8. Now I'm saying int num max is equal to 90, 80, 30, 60, 100, 70. So num is an array of size 8. So see, you can see here I have created an array of size 8, and the first 6 elements are filled by the values which are given here. Then I'm declaring 3 more variables in main: n, which is of size, which is the total number of elements present in the array, and it is 6. Then position is the position where I want to insert the new element, and data is the new element, value of the new element which I want to insert in this array. So if you now see the insertion function, the formal parameters, we will see how they are declared in insertion function. Now A is the name of the array, and I think you know that the arrays are never passed by value. They are always passed by reference, or you can say pointer. So this you will discuss in detail in the pointer chapter. So you can see here A is nothing but it will point to num. So whatever changes you will make in A, that will be done in num also. Then int ampersand n, it means we have passed n by reference. So no memory space is allocated to n. It will share the same memory space, and this memory space has both name small n and capital N. Then I have declared a variable, this is passed by value. So I have declared a variable position which has the value 3 passed from pos, and I have declared one more variable item, and the value of which is passed from data, which is 40. So item will take the value 40. So this is the memory diagram of my program. Let's see the working of the program. Now in the program working, see in the beginning this is my array which has 8 elements: 90, 80, 30, 60, 100 and 70. Now we are saying j is equal to n minus 1, and n is 6. So j will become 5, and j will become 5. So this is 5, and we are saying aj plus 1 is equal to aj. Aj plus 1 is equal to aj means a6 is equal to a5. So the content of a5 will be copied to a6. You can see here the content of a5 is being copied to a6. Now we are saying j minus minus. So when we say j minus minus, the value of j will become 4. And again we are saying aj plus 1 is equal to aj. So a4 is copied to a5. So you can see the content of a4 which is copied to a5. Now again we will say j minus minus. So j is equal to 3. So again A3 is copied to A4. You can see here A3 is copied to A4. And when I say j is equal to 2, this is the index number 3. So again now the j has become 2. So this is the index number where I want to insert my data item. So when I say a position is equal to item, so this will be inserted. 40 will be inserted at this position. You can see here initially it was written 60 here, and now when I will insert the data item, it will become 40. So this is how the insertion takes place. You can see the loop again. You can see the loop again. Again, we are saying the same thing here. A j is equal to n minus 1, j greater than equal to position which we have sent here, and j minus minus. Unless or until j is not less than position, this loop will continue and all the elements will be written one step below. And at the end, we are saying a position equal to item. The space has been made for this item and this will be inserted in the array, and then I am incrementing n also. The number of element has incremented by 1. Now let us see how we can insert in the sorted array. So in this we are trying to insert an element in the sorted array and we have to find the position in our own. Position is not given to us. So again the same program, we have iostream.h and process.h. Process.h is for exit function which we have used here. We are declaring a constant integer for the size of the array, and then we are saying main. In main I am declaring an array and of size max, and these are the data items which are already inserted in the array. And then n is equal to 6. It means 6 elements are there in the array and the data I have to insert is 15. Now this time position is not given to us, so we will pass only 3 elements: num, which is the array name, the number of elements which are present in the array, and the data which I want to insert. So if I look at the program function, void insertion, again a is the array, n is passed by reference because n is going to change here, and then item is the item which I want to insert in the array. So if I say if n equal to max, if other n and max they are same, means the total number of elements which are present in the array and the total of number of elements which can be inserted in the array. If they are same, it means the array is full and we will see out overflow and we will exit because no more element can be inserted in the array. Now we are declaring two variables j and pause for the functioning of this function. Now if we are checking if item greater than equal to n minus 1, if the item which we are going to insert is greater than the last element of the array, then we are simply saying an is equal to item because this array is sorted. So if last element is less than the item which I am going to insert, so I can simply say an is equal to item. Else I will say I will first find out the position. So I will initialize pause by 0 because the first element index number starts from 0. So while a pause less than equal to item, while the elements in the array are less than or equal to item, I will keep on incrementing pause. I'm trying to insert the position where I want to insert an element. Then again the same thing which we did in the previous program. For j is equal to n minus 1, j greater than equal to pause, and j minus minus, I will, for this number of times, I will move all the elements one step down. Aj plus 1 is equal to aj. And then I will say a pause equal to item. Now I have made the space for the item which I want to insert, and I will say a pause equal to item, and then simply I will increment n by 1 because the number of elements have been increased by 1. So we look at the memory diagram to make it more clear. So again it is divided in 3 parts: global variables, main, and insertion. Global variable, there is one global variable max which is of type constant int and it has value 8. Then this is the array num which has already 6 elements, and this time you can see that all the elements are in the sorted order, and then n is 6 here, already 6 elements are here, and the data which I want to insert is 50. And if you look at the insertion function, so a is the name of the array and it will share the same memory space as n as num, and capital N is passed by reference, so n and n they will share the same memory space, and the value of data will be copied to item. This is passed by value, so there are new memories allocated to item and data will be copied to item. So let us see the memory diagram, how the operations are taking place. So initially we are saying pos equal to 0. If the element, first we checked whether our element is greater than the last element or not, but the item is 50 and the last element is 86. So 50 is not greater than 86. So it means it has to be inserted in between somewhere. Otherwise we could have simply written an is equal to item. Now we have to find out the position. To find the position, initially we are initializing pos by 0 and we are saying while a pos less than equal to item. So देखिए pos equal to 0, a0 less than item. What is a0? a0 is 27 and item is 50. So 27 is less than 50. So the condition is true and pos will be incremented by 1. So pos will become 1 and now again I will check whether a1 is less than item or not. a1 is 38 and item is 50. So 38 is less than 50. So again the condition is true and pos will be incremented. Now pos will become 2. And again we will say, we will check whether a2 is less than item or not. a2 you can see is 46 which is less than 50. So the condition is true. So again pos will be incremented by 1 and pos will become 3. Now again we will check a3 is less than item. What is a3? a3 is 52. No, a3 is greater than item. So this loop will break and we will go to the next statement. We have found the position. It means we have to insert the element at this position. So we have to move all the elements one step down. Because if we do not move them, it will be overwritten at this position. So this 52 will be removed and it will be overwritten by 50. This we do not want because this is insertion. Insertion means already existing elements should remain in the array and we are inserting new element in the array. So we will make a space and we will move all the elements one step down. Let's see how. J is equal to n minus 1. J is equal to n minus 1. N is 6, so it will become 5. A6 is equal to AJ plus 1 is equal to AJ, which means A6 is equal to A5. So this is 6. So 86 will be copied to A6. Then we will say J minus minus. So J will become 4. And now A5 is equal to A4. So you can see A5 is equal to A4. This is A5 and this is A4. So A5 will be copied to A4 will be copied to A5. So again J minus minus. So A4 is equal to A3. So it means A3 is copied to A4. And again J minus minus. Now the J will become 2 and position is 3. The position which we calculated was 3. So 3 is not less than 2. So the loop will break. And now we have written a pos is equal to item. So pos is nothing but 3. So a pos equal to 50 when we will say, so 50 will be written here. So 50 will be written here. You can see here all the rest of the elements are maintained in the array and one more element is inserted in the array. So I have written n plus plus, which means n is also incremented. Now we have 7 elements. 1, 2, 3, 4, 5, 6, 7 elements. I hope you have understood this. Now let us see how we can delete from an array. Deletion refers to the operation of removing an existing element from the array. So we have written a program for removing an element from the sorted array. So let us see how we can remove. So if you look here, so this is the header file. We are declaring a constant integer max which has value 6. 6 is the size of the array. Then I am declaring an array num with size 6 and I am assigning some numbers to it. N is equal to 6, which is the total number of elements present in the array, and data which I want to delete from the array is 40. So for the function deletion, I am sending num, n and data. So the array A will take the same memory space as num, and n there is passed by reference, so they will also take the same memory space, and item and data. They will this is passed by value, so the value will be copied to, the value of data will be copied to item. Now if I say int I and pos is equal to 0, two variables, so we are checking if n is 0, then this is underflow. It means array is empty and we will exit from here. This is missing here. You can write down exit from this because if the array is empty, we cannot delete an element from the array. So we will exit from this position. Now while a pos less than equal to item, pos plus plus. Now we are trying to locate the item, position of the item which we want to delete. So we are saying while a pos is 0 in the beginning. If it is less than equal to item, we are saying pos plus plus. So our position of the item will come here. If a pos equal to item, there can be two cases. Either the item will be found or item will not be found. If the item is found, then what we will do to delete an item, we will move all the elements one step up. To insert an element, we were moving all elements one step down, but to but to delete, we will move all the elements one step up. We'll start from the position +1 until the end of the array, and you can see here ai minus 1 is equal to ai. So we are copying ai to ai minus 1. On the end, we will make it 0 because this element is of no use now. We will make it 0, and we are saying n minus minus, which indicates that one element has been deleted. So we are deleting the total number of elements present in the array, and in the end we are displaying element deleted. And if a pos is not equal to item, we are saying element not present. Let us see the memory diagram of it. And so here again the memory is divided into three parts: global variables, main, and deletion. And you can see here this is constant in max. So this is the global variable which has the value 6, and int num max is the name of the array which has all the memory. Memory of size 6 is allocated to it, and these values are filled in this array. Then we have a variable n which has value 6, which is the total number of elements present in the array, and this is the data which we want to delete from the array. I will call the function deletion. Deletion, we have an array A which will refer to array num only, and then n and n, they will share the same memory space, and item is passed by value. So value of data will be copied to item. Now we have to delete 40 from the given sorted array. So item is 40 here. So let us see how these loops works. While a pos less than equal to item pos plus plus. See, in the beginning pos is 0. So a pos is 10. 10 is less than item, which is 40. So you can say, so this condition is true. So it will go here and the pos will be incremented. Pos will become 1. Now pos is 1, you can see. Now again we will check a1 is less than item or not. a1 is what? 20. 20 is less than 40. Yes, the condition is true. So again pos will be incremented. Pos will become 2. Now again we will check if a2 is less than item or not. a2 is 30. 30 is less than 40. Again the condition is true. So again we will go to a pos plus plus. So pos will be incremented and pos will become 3. So now we will say a3, we will find that a3 is equal to item itself, which we want to delete. So item has been found at the position 3. Now what we have to do to delete this element, we will move all the other elements one step up. So you can see here I is equal to pos plus 1, which is equal to, if you see here the item has been found, I is equal to pos plus 1. Pos is what? 3. So I is become 4, and we are saying ai minus 1. ai minus 1 is 3. a3 equal to a4. So a3, the value of a4 will be written to a3. You can see here a4 will be written to a3. Now I will be incremented by 1. I will become 5. And now the value of a5 will be written to a4. You can see. And again I will be incremented, and this time I will become 6, and the condition becomes false. So we'll say a n minus 1 is equal to 0. So the last element we are making 0 here. And this is not mandatory, this is your wish. And n minus minus I'm saying because one element is less now. The array has only 5 elements instead of 6. And we will displace our element deleted. So this is all for this session, and if you like this video, kindly give thumbs up and subscribe to my YouTube channel. Thank you and have a nice day.